To determine congruence, two shapes will be congruent or two figures will be congruent if there is a series of rigid motions that will map one onto the other. In this case, these two puzzle pieces are congruent because we can do a reflection. Completing this vertical reflection will allow the pieces to overlap. Here we have an example of two shapes that are not congruent. We can see that one is bigger, larger than the other. And whenever we are determining congruence, all the points from the pre-image must be mapped onto the image. In this example, the shapes will be congruent as long as we perform a rotation. (90 degrees clockwise, followed by a reflection across this vertical line. So first we need to rotate the image so that the colors are aligned and then do a reflection across that vertical line. Now in your notes, it's your turn to try it out. Are the shapes congruent? For shape A, we can see that we can do a 90-degree rotation clockwise and then a vertical reflection or a translation to get the shapes to overlap. Like I said, after the rotation, you can also do a translation. In shape B, we can see that they do not have the same shape, so the shapes cannot be congruent. There is no rigid motion that will take one onto the other. Let's look at an application problem. A boat builder plans to connect two pieces of wood using puzzle joint as shown in the picture. For a successful joint, the units must be congruent. One transformation would be to rotate unit A 180 degrees on the top left corner, and after performing that rotation, you would have to translate it to the right and then translate it down so that it overlaps onto unit B. It's your turn to think about a different composition that would take that unit A onto B. Let's look at the do you understand? Now our essential question is, what is the relationship between rigid motions and congruence? The main thing is that if two figures are congruent, a composition of rigid motions maps one figure onto the other. Question number 2, error analysis. Taylor says that trapezoid ABCD and trapezoid EFGH are congruent because he can map one onto the other by multiplying each side by 1.5. What was his mistake? He is changing the size of the trapezoid. He's performing a dilation, and a dilation is not a rigid motion. Vocabulary. Why is a rigid motion also called a congruence transformation? Because the shape and the size of the figure does not change. Question number 4. For any two line segments that are congruent, what must be true about the lengths of the segments? There exists a series of rigid motions that maps one onto the other. Construct arguments. A composition of rigid motions maps one figure to the other. In each intermediate image in the composition congruent to the original and to the final figures? The answer would be yes, because if I'm performing rigid motions do not change the shape or size. Communicate precisely. Describe how you can find a rigid motion or composition of rigid motions to map a segment to a congruent segment and an angle to a congruent angle. The very first step is to translate so that one corresponding point is overlapping. And then you want to rotate the shape centered on that corresponding point to get another point to overlap. Now for the line segment, this is going to be enough. But for the angle, you might have to perform a reflection using the line segment that's already overlapping as your line of reflection. You guys can use patty paper on this section, but remember that when you're looking for a series of rigid motions that will map one onto the other, you always want to mark the points that are corresponding first. Okay, here, once I connect all the corresponding points, I can see that they all intersect at 0,5. So I can go ahead and perform a 180-degree rotation centered at 0,5. You guys can use patty paper on this section to help you determine which triangles are congruent. Okay, comparing these triangles, I can see that this line segment corresponds to a triangle, a right triangle, with legs 2 and 1. And that would correspond with this segment. Same triangle, legs 2 and 1. This section, which is the longest side of this triangle, and I made a right triangle here that has a leg of 1 and 4, will correspond with this section. And then we see the other part too. So they correspond. So that means that these two triangles are congruent. Remember that when you're writing your congruency statement, you need to make sure that the corresponding sides are written down correctly. So in this case, I would have triangle GHJ would be congruent to triangle KLM. Now for this other set, I can see that the longest side of this triangle would correspond to a right triangle with legs of 4 and 3. And it's the same thing that I have here, legs 4 and 3. So these two parts are corresponding to each other. Same thing here, 2, 1, 2, 1. And then the final one, which is 1, 3. Legs of 1 and 3. Draw your congruency statement. Triangle ABC is congruent to triangle D, corresponds with A, E corresponds with B, and F corresponds with C. I have the last question cut up here, but we're supposed to determine if figure A and figure B are congruent, and if they are, there has to be a series of rigid motions that would take one onto the other. I would encourage you guys to use patty paper on this section. But it seems to be that they are congruent. I would have to perform 180 degree rotation. And then after that, we can do a translation. There's more than one series of rigid motions, so if you thought of something else, we can discuss it later if you want me to make sure that it does map onto the other.